Today on How It's Made, Stagecoaches, road reflectors, fire-baked pottery, and custom motorcycle tanks. Transported passengers and goods. The coach would travel an established route in stages, but over time, the word stage was used to describe the coach itself. Drawn by 2 or 4 animals, it relied quite literally on horsepower. Like a classic movie scene come alive, seeing a stagecoach in action is a throwback to a bygone era. Even today, building a stagecoach, horse-drawn carriage, or covered wagon borrows techniques from a time when engineering and design were done by hand. The creation of the stagecoach begins with drawings detailing both the look of the final product and its exact dimensions. They start with construction of the stagecoach body. A worker puts framing rails for the back wall into place using a mortise and a tenon joint. The final panel slides into place, and another framing rail holds the end wall together. The end wall is added to other pieces of the stagecoach body that have already been assembled. The end wall has ribbing for added strength. Although the floor is partially curved, passengers will sit or stand on the part that is flat. The coachmaker inserts the door pillars into the mortise with a few taps of a hammer. He lowers the roof beam onto the top part of the door pillars and fastens it firmly into place. Forging of stagecoach suspension components is done by hand. The blacksmith begins stretching the heated bar of steel into a component called a jack. He repeatedly heats and hammers the steel bar until it reaches the desired shape. He hammers the tapered steel bar over an anvil to shape it into a curved hook. Once the hook becomes an eye, he hammers a pin into it. The blacksmith wraps the heated steel around the pin to form a snug joint. The transformation is done without the help of presses or dies. It's the blacksmith who essentially sculpts the metal bar into a piece that has both function and form. The blacksmith positions the finished and cooled jack onto the undercarriage and attaches it firmly into place. The assembly has to withstand the stresses of the leather suspension used to make the stagecoach ride more comfortable for passengers. Using a clip, the blacksmith attaches the step used to climb into the stagecoach to the jack assembly. He attaches a clevis to the jack assembly. With 4 jacks in opposing corners, the leather suspension will rest in the clevises. Now onto the stagecoach interior. The trimmer inspects the hide of leather. He positions patterns carefully, choosing leather cuts that match. Then he'll cut the leather pieces, with each pattern designated for a specific part of the stagecoach. He places the newly upholstered cushion on the seat bench and buckles the retaining straps that hold it securely in place. In the paint booth, this particular undercarriage is given coats of yellow and black stripes. A worker coats the running gear and wheels with sealer to weatherproof the undercarriage. Workers gently lower the newly painted and upholstered wagon onto the undercarriage. They connect the two using mounting bolts. They fix the nameplate to the center of the rear axle. To help protect passengers from the elements, this particular model comes with a roof. Workers lower the roof posts into receiver eyes and make sure they're securely attached. Next, a worker positions a brake pad against one of the rear wagon wheels. He then tests the brake assembly. The face of the brake pad can be wood, steel, or rubber, depending on the vocation of the wagon. Now for a suspension test. The process that began with raw lumber and steel ends up about 1,200 hours later with a stagecoach that's ready to hit the dusty trail. Road reflectors originated in Britain in the 1930s. A cat's eyes reflected in headlights on a foggy night, alerting a driver to the fact that he was about to veer off the road, provided the flash of inspiration. The driver went on to invent a mechanical version of the cat's eyes, reflective road studs. Today's reflective road studs are shining examples of innovation. These versions are computerized and solar-powered, so they're energy efficient and they'll function in a power blackout. It takes more than 20 parts to make one road reflector. The assembler first solders 2 wires to the back of a solar circuitry board, establishing a connection. She flips the solar circuitry board around and applies double-sided tape. She places 2 strips of copper on conductive pads in the corners above the tape. She removes the backing from the double-sided tape. Using a vacuum tool, she transfers the solar cell to the tape. Once in place, she turns off the vacuum and smooths the cell to the tape. She solders the copper strips to the conductive pads, creating the circuitry. She connects the solar panel to the board with short little wires called jumpers. She slides rubber protectors onto the board. Each road reflector will have 2 of these solar units. Next, she assembles the flashing LED lights. She solders wires to the back panels to link the lights to the main computer board. She then applies adhesive to the panel and presses the framework for the LED lens to it. She inserts the polycarbonate lens into the framework and it clicks in. There are 2 LED lights per road reflector. She now assembles the reflector. She angles shiny aluminum flaps to bounce light. She tucks the lights into the reflector and they adhere to the double-sided tape applied to the base. She powers up the flashing lights and checks the intensity and the effect of the reflective flaps. Things are looking good, so now she inserts foam in a slot at the center of the aluminum casing. She places the reflective light unit on it. She installs a foam-wrapped rechargeable battery in a compartment on one side of the lights. She places the main computer board and solar cells in the compartment on the other side. And then a computer technician programs the road reflector to interface with the control system on the street pole. The reflector is now ready to stop traffic, or at least slow it down. A crew carves a slot in the road, sized precisely for the reflector. To keep the pavement clean during installation, one of them tapes the perimeter of the hole. He then pumps industrial-strength epoxy into it. He inserts a cast iron framework into the epoxy-filled hole. He wipes up the epoxy overflow and removes the tape. Entrenched in the pavement, this cast iron framework will encase the road reflector, allowing it to hold up to heavy traffic. He screws a protective crossbar over the lights and then secures the road reflector to the support structure. They install the wireless communication system atop a pole. This positions it to activate the road reflectors when the curbside crosswalk button has been pressed. Modern communications technology has improved on this 1930s invention. Today's road reflector systems are flashier than ever. Designed to attract a driver's attention and keep it on the road. In tribal communities in the American Southwest, pottery takes shape much as it has for 2,000 years. In the hands of native artisans, mud becomes a cooking pot or a storage vessel. No pottery wheel necessary, no kiln required, just a roaring campfire. Times may change, but in the Southwest, tribal culture is true to its roots, creating pots that look like ancient artifacts, except they're new. Crafted from local clay, the pots are both lightweight and durable, and their appeal is truly timeless. The potter gathers her own clay. This is micaceous clay from volcanic deposits in New Mexico. She also mines minerals like iron oxide to paint the pottery. In its raw form, micaceous clay sparkles in the sunlight. Its natural glitter will make the finished pottery shimmer. She picks out leaves and tree roots because anything organic will outgas and cause the pottery to crack. She transfers the clay to a bucket of water. After 3 or 4 days, it dissolves, and she filters it to remove smaller contaminants. Once the clay thickens to a gravy-like consistency, she transfers it to a fabric-lined mold. She leaves it to set and coagulate to a dough-like consistency. She kneads a chunk of it to remove air bubbles. She then shapes it into a bowl. It will serve as the base of a traditional storage pot. She scrapes the pot base inside and out to thin it as it dries. The thinning process also works the clay into a harder state. She moistens the tip of the bowl to make it malleable and flattens the edge, creating a foundation to build up the pot. She now rolls another piece of clay into a long, thin strand and coils it around the pot. She blends the strand into the pot base and then shapes it to extend the pot upward. The process is called coiling. She continues to build up the coils, blending them until they become completely enmeshed and seamless to the rest of the pot. As she coils and blends, she turns the pot inward, creating a shoulder near the top. She smooths the lip and thins the extensions to ensure the thickness is consistent. This will prevent structural weakness. In the hands of a skilled artisan, a lump of clay has become a pot, but there's more work to be done. She narrows the opening. She cuts the lip in 6 symbolic orientations, representing north, south, east, and west, the sky, and the earth. She scallops the edge in the direction of the cuts to accentuate them. She smooths the pot with a wet sponge. Before dawn, when the wind is low, she lights a fire and places the pots directly into it. She stacks wood around the pots and flames engulf them. This changes the clay's molecular structure so that it can never turn back into sticky mud. She covers the fire with a metal tub. The flames subside and the pots cool. Curing clay over an open fire isn't an exact science. Heat is uneven, and this causes fracturing. 20% of these clay pots will be damaged. She examines them carefully and rejects anything that is not intact. In addition to the micaceous clay pots, she also fires some red clay ones. She paints geometric motifs onto those, using the mineral paint she's prepared herself. Each pot is one of a kind. Quality varies depending on the nature of the clay and smoke patterns created during firing. She leaves the pots made of micaceous clay unpainted for traditional reasons. She signs the base and includes the name of her tribe. She tucks her biographical information into it. She's been making pottery since childhood. From a handful of mud to a storage vessel or cooking pot, Southwest native pottery continues to be a triumph of ingenuity. As a group, motorcycle riders aren't big on convention. So when it comes to the look of their ride, they often go their own way. The gas tank presents the greatest opportunity when customizing the facade of the bike. Prominent and up front, the tank both fuels the ride and defines it. On a car or truck, the gas tank is tucked away out of sight. But on a motorbike, there's no place to hide it. So you may as well just show it off. To make a custom gas tank, the metal worker starts with a sheet of sturdy, cold-rolled steel. He traces around paper patterns to transfer their outline to the steel. There are 7 pattern pieces. The design is a tapered classic one. He follows the lines with an electric metal shear. With it, he can produce a rough cut quickly. He switches to a lever-operated shear to trim the parts cleanly and precisely. He physically bends one piece around a tube to create the tunnel. The tunnel is the lower section of the tank that fits around the backbone portion of the bike frame. He cuts the tunnel to size along marked lines. He drills holes in the tunnel for the mounting tubes. Using threaded bolts as guides now, he positions the 2 mounting tubes on the holes and welds them to the tunnel, creating leak-proof seams. With rods attached as a mock-up of the rest of the tank, he tests the fit to the bike. He confirms the handlebars move freely and that there's no interference with the engine. Next, he uses an English wheel on the 2 top panels. He rolls each panel between 2 wheels to take the profile from flat to curved. He tests the curvature against the mock-up rods. It needs tweaking. He continues to shape it until the custom gas tank part matches the mock-up perfectly. Using another machine now, he forms a stylish curl onto the edges. This will also allow the 2 parts to be joined neatly at the peak. After marking the location of the fuel cap, he punches small holes for mounting screws. He cuts out the hole for the gas cap. He joins the 2 top sections of the custom gas tank with tack welds. A more permanent weld will come later. He drills holes for mounting the top panel assembly to the tunnel, spacing them to correspond with the mounting tubes. With the mock-up rods removed from the tunnel, he joins the top panel assembly to it. He then tack welds the sides to this custom gas tank assembly. He hammers the tank's front cap against a form to give the outer edges a rounded profile. He sands the part around the edges to fine-tune the contours and ensure a perfect fit. He tack welds the front cap to the rest of the motorcycle tank. And with the tank structure complete, it's time to make it leak-proof. He does a full penetration weld on every seam. Using a pneumatic tool, he sands the seam smooth and flat. He then sands the rest of the tank by hand to make the entire surface uniform. He positions the tank on the bike. After equipping the gas cap with a gasket, he screws it tightly to the custom tank. Using mounting screws and wing nuts, he secures the tank to the bike frame. This custom gas tank now becomes a canvas. He paints it and applies silver borders and graphics requested by the customer. He connects the tank to the carburetor, and this bike is ready to show off its new custom look. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at sciencechannel.com/howitsmade.